Is it audible? Is it audible? So let us start. Finite differences and interpolation. Okay. So in this finite differences and interpolation, right? So what we are going to study is, so if there is a set of tabulated data, from there actually we wanted to find out the interpolated or extrapolated value, which essentially means that suppose if we have the equation y is equal to x plus 10, so this is a straight line equation, and this straight line equation, is it audible, Vishal? Can somebody confirm? Is the voice is clear? Okay. So if we have this equation y is equal to x plus 10, now this equation, so from this, right, so what we can do is, so this is x and this is y, and then this is a straight line equation representing this value. Now here actually from this relation we can easily get whatever may be the value of x, you can easily find out the value of y. Suppose actually if I wanted to calculate the value of y at x is equal to 10, then I can substitute here, and 10 plus 10, which is the value of y, is equal to 20. So this way actually I can find it out. Now here we have a straight line equation, and this straight line equation, if you wanted to bring it out, then actually you just need two different points. So if you have the values of x1, y1, and if you have the values of x2, y2, and then you can easily find out the relation between these two. From the relation, y minus y1 is equal to y2 minus y1 divided by x2 minus x1 into x minus x1. So this is the relation which will talk about the straight line equation. Now here, this is a linear equation if you notice. So this linear equation, two different points are sufficient enough to find out whatever may be the value of x, I can easily find out the value of y. So with the assumption that this is forming a straight line equation. Now suppose actually if I have a data like this, so which will represent the points like this. So this is the curve I am talking about. Now actually in this curve, though I note any points, like actually I have got 1, 2, 3, 4, 5 different points. But though I know 5 different points, if you ask me what is the value of y at a value of x is equal to 10, let us say, then actually it is very tough for me to find out this particular value, because this is not following any specific relation. Got it? So this is not following any specific relation. Hence actually this is a challenging task. So what is the value of y when you specify a value of x? So this is exactly what we call as the curve fitting. So interpolation or extrapolation is also one kind of curve fitting, where if you have a set of tabulated data, from there actually you are trying to find out the value of y for a corresponding value of x for which the data is not available. So that essentially means that we are trying to find out an unknown value of y for a given value of x. So with the help of this interpolation. Interpolation meaning, suppose if you give two different points here, then actually based on the relation of this entire data, you will be able to find out whatever may be the value of x actually in between these two values, you will be able to find out the value of y from the information of this tabulated data for the entire set. And this is what is called the interpolation. And the extrapolation is given two different points, then actually if you are asked to find out the value which is outside the range between a and b, so this is a and this is b. If you are intended to find out the value of y for a value of x which is outside this range, then that's what is called as the extrapolation. So So this is being a curve, this is a little complicated. But actually, if I explain from this relation, interpolation, if I know the points of A and B for any value of x which is in between these two, so this is, let us say B, then you will be able to find out the value of y. So this is the value which we calculated by interpolation. Here actually, I know only A and B. If I wanted to find out the value of y at x is equal to 10, where the point is C is outside the range of A and B. And if you are finding out the value of C, then actually this is through extrapolation. Interpolation meaning in between and extrapolation meaning outside the range. Got it? So with the help of the tabulated data, without knowing the relation whether it is a linear or non-linear, if you know a set of tabulated data, the process of finding out the value in between the range it was asked or the value which is outside the range which was asked, then actually if you are able to find out, that's what we call as the interpolation. Got it? So interpolation is the process of finding the value of y of a dependent variable between the range of two dependent variables, two values of dependent variable right. So this is the process, and extrapolation is finding out of y for a value of x which is outside the known range. So this is the extrapolation. Got it? Yeah, you can note down this. Vishal, I hope you got a clarity, so I have repeated. Then, so this is being the linear relation, right? So you will be able to find out any value easily. But this is being a non-linear, so non-linear relation, it is very tough to find out this non-linear relation. Now here actually, I wanted to extend this discussion. So nowadays actually artificial intelligence is becoming so popular, and if you notice, the complete problem statement of artificial intelligence is, in mathematics terms, it is just curve fitting, nothing more than that. So for a given set of values, if you are able to find out a curve which will fit those values, and then you can interpolate or extrapolate for any particular value of your own interest, which essentially means that guessing an unknown value with the known data, that is artificial intelligence. Now for our mathematics purpose, this is simply a curve fitting process. So for that actually, for very complicated set of data, complicated means it is not following any particular set of relation, then actually even such kind of data also, if it is available, and then with the help of neural networks, right? So we are trying to fit a curve which will satisfy that relation for any given unknown data. Got it? So that is artificial intelligence. Finally, it is a set of data for which you are doing a curve fitting. Got it? So interpolation also is one such kind of thing, but at very, very low level. That means here actually interpolation and extrapolation, you are trying to find out one value for a set of known data of maybe 10, 15 data. But artificial intelligence actually it will try to process maybe crores of data points, and then finally whatever maybe the data points you wanted. So you will be able to find out for the unknown values of the independent variable there. So this is exactly the same thing, but actually in a macro level there. So in this particular topic, right, so as per our syllabus, right, so we have actually two different kinds of interpolation methods. One is Newton's interpolation formula. And the second one is Lagrange's. So these are the two parts actually which we need to be discussing. But for this actually to understand, you need to understand finite differences. Now these finite differences are essentially the difference between two different points. That is, for a set of given data, so if you are able to find out the differences between the consequent points, so that's what we call as the finite differences. Suppose, so there are actually three different symbols actually that are going to be used here. One is the forward difference operator. And this is represented by a letter called delta. And the second one is the backward difference operator. And this is represented by the letter called del. And the third one is central difference operator. And this is this kind of delta. So this is also a delta and this is also a delta. This is called as del. And here these two are actually called as del, but with different kinds of symbols. Now suppose if we have a data of y0 and y1 and y2 like this. So here actually y0, y1, y2, y3. Now here the forward difference operator is defined in such a manner that so delta of y0 is equal to y1 minus y0. And this is delta of y0. So this is actually for this particular data, we are trying to find out the forward difference. And this forward difference is y1 minus y0. Then delta of y1 is called as y2 minus y1. Delta of y2 is equal to y3 minus y2. Delta of yr is equal to yr plus 1 minus yr. So this is the general formula for the forward difference. And for this particular set of data, so here actually if you want to find out delta y0, so this is going to be y1 minus y0. And this is y2 minus y1. And this is y3 minus y2. So this is how actually you will be finding out the difference of the values, which we call as the forward difference for the set of data of these y values. Similarly, the second level of set of operator, that is delta square of y. So delta of y here and delta square of y, which is the difference of these two. So this is represented as delta y0, and this is represented as delta y1, and this is represented as delta y2, and then the difference of these two. So this is delta y1 minus delta y0, and this is called as delta square y0. So the difference of these two now. this minus this one is treated as delta square of y naught, and this value delta square of y naught. And here actually the difference between these two, that is delta y2 minus delta y1, and this value is called as delta square of y1. So for this one, so if you notice, this is coming here, this will always come. And then so actually this is a kind of triangle like this, it is going to vanish out. So this is the kind of triangle you are going to get it, and finally it will vanish at certain point. Got it? So do you have any questions on these forward differences? And exactly in the similar manner, even the backward difference and the central difference also comes into picture. Now here actually these are all the basics that we need to understand this interpolation formula. Got it? So because actually this Newton interpolation formula can be expressed in the forward differences and the backward differences format. Okay, so you can note down this. Done? Okay. So here actually, if you further extend this relation, that is for a set of values of x0, y0, x1, y1, x2, y2, and x3, y3, x4, y4. Now for this actually, the first forward difference is delta y. So delta y is y1 minus y0, and here y2 minus y1, y3 minus y2, and here y4 minus y3. And delta square of y, if you want to find it out, now here actually, so this is called as delta y0, this is delta y1, this is delta y2, and this is delta y3. Now here, if you want to find out delta square, then the difference of these two, delta y1 minus delta y0, delta y2 minus delta y1, delta y3 minus delta y2. So this is delta square y0, and this is delta square y1, and this is delta square y2. Now here, if you want to calculate this value in terms of x0 and y0 and y1, and this can be delta y1, you can treat as, so this one, y2 minus y1 minus y1 minus y0, and this value is y2 minus 2y1 plus y0. So this is how actually we are going to get it. And then here actually what you can get it is, so this is delta y2 minus delta y1. So delta y2 is y3 minus y2 minus y2 minus y1. So this is y3 minus 2 times of y2 plus y1. So like this actually you can get the values of here. Now here actually again if you find out the next level of difference, that is delta cube of y. So this is delta square of y1 minus delta square of y0. So delta square of y1 is going to be, so this is delta square of y0, and this is going to be delta square of y1. So if you find out this delta cube y, delta square y1 minus delta square y0, this is going to be delta square y1 is y3 minus 2y2 plus y1 minus y2 minus 2y1 plus y0. So this is y3 minus 3y2 plus 3y1 minus y0. So this is how actually you are going to get the values here. Is it audible? Okay, fine. So like this actually y3 minus 3y2 plus 3y1 minus y0. Now this is how actually you get it. Now actually if you try to correlate the binomial expansion here, so we know that this is x plus y whole square is equal to x square plus 2xy plus y square. Here x plus y whole cube is equal to x cube plus 3x square y plus 3xy square plus y cube. Now if you notice here actually the binomial coefficient 1, 2 and 1, and here in this operator, that is del square, so del y, right? So del square y value actually we have calculated, and this is coming out to be y2 minus 2y1 plus y0. Now here with an alternate sign of plus 1 here, minus 2 here and plus 1 here. This is the coefficients. Now plus 1 minus 2 plus 1. Only thing from here it is changing. This is plus 1 and this is, instead of plus 2 it is going to be minus 2 and this is plus 1. That means with plus and alternate sign of minus and then plus and then minus, like this actually it will continue. Now if you try to consider del cube of y, if you calculate it, this is coming out to be y3 minus 3 times of y2 plus 3 times of y1 minus y0. Here actually x plus y whole cube, if you try to expand with the help of binomial expansion, x cube 3x square y plus 3xy square plus y cube. The binomial coefficients are 1, 3, 3 and 1. And here if you notice, with an alternate sign of plus 1 here, minus 3 here and plus 3 here and minus 1 here. So plus 1 minus 3 plus 3 minus 1. So like this actually you are getting the values of the coefficients, the binomial coefficients, and the difference operator coefficients are one and the same with an alternate sign. Got it? Just a minute, I'll change the battery. Okay, so is it better now, voice? Is it better? Oh, fine. So this is how actually you can correlate with the binomial coefficients. Now this is actually, we are trying to find out for a set of tabulated data, we wanted to find out the forward differences, right? So the applications of this actually will be down the line, it is going to be discussed. But first of all, we need to understand what is the forward difference at all. Got it? So you can note down this relation. Then so in general, you can write this nth difference. You can straight away write it. So del power n y naught is going to be yn minus nc1 y n minus 1 plus nc2 y n minus 3 minus nc3 y n minus 3 plus dash 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 up to y naught ncn y naught. So this is how actually you can express any forward difference in this particular format. Got it? Now coming to the backward difference and the forward difference, right? The calculation part is one and the same, but the convention is different. So the convention is, if you have a set of data x0, y0 and x1, y1, x2, y2, x3, y3, x4, y4, let us say this is a set of tabulated data. For this particular tabulated data, if I wanted to define a reverse operator, that is the backward difference operator, and this backward difference operator is operated on the next value than this value. That means here actually delta y1, del y1, this is how actually you are going to express rather than del y0. Earlier actually we tried expressing in forward difference as del y0, but here actually it starts with y1 and then the value is going to be one and the same, y1 minus y0. So the difference between these two is del of y1. Earlier actually del of y0 is expressed as y1 minus y0. Here the same value is represented in a different particular format. So this is a backward difference operator. Now here del of y2 is going to be y2 minus y1 and del of y3 equal to y3 minus y2 and del of y4 equal to y4 minus y3. So this is how actually you can express in reverse format. Got it? So similarly, del square of y. So this is del of y. Now this is again del square of y1 can be expressed as del square y2 minus del square y1. So the difference between these two is operated as del square of y1. So rather than coming from this line, this is going to come in this particular line. Got it? So here del square of y2 is, so del of y2 is y2 minus y1 minus y1 minus y1. So this is going to be y2 minus 2y1 plus y0. So this is how actually you will express, but you are going to get the same values but with a different kind of technology. Yeah, got corrected. Yeah. So this is how actually you can express exactly the same thing but actually operated from bottom to top rather than the top to bottom. So here the general term is going to be, so del of yr can be expressed as yr minus yr minus 1. So this is the del operator. In case of forward difference operator, yr can be expressed as yr plus 1 minus yr. So this is how the general term is different. Got it? So in general, del of yn for the last term is going to be yn minus yn minus 1. This is for the last term and this is the general term. This is for the backward difference and this is for the forward difference. Got it? So, but the convention is different. The values whatever we have calculated are the same. Got it? Okay, you can note down this. Yeah, so you are right. So this is actually del square of y2. Now it is correct. So that fits your understanding. So del square of y2 is equal to del of y2 minus del of y1. Got it? So actually it comes in this particular format, this kind of triangle. So bottom to top. Actually forward difference actually y0 comes in this particular line. Now here in this case yn comes in this particular line rather than coming from this line. That is the difference. Earlier actually if you notice, this is delta y1 and then delta y0, delta square of y0 and delta cube of y0 actually you are getting here. But here actually delta yn and delta square of yn, delta cube of yn, like this actually comes from the bottom to top. So here the operator is the next one comes here. So that's why delta y1 is equal to y1 minus y0 and delta square of y2 is equal to delta y2 minus delta y0. So here actually you keep on incrementing one by one. Yeah. Got it? Noted down. So the central difference actually, this is also the same thing, but actually expressed in terms of the middle. Here delta of y, so here actually y0 plus, so this is 0 plus 1 by 2. So this is actually delta of y 1 by 2. This is how actually it will be expressed. So delta of y 1 by 2, this value is expressed as y1 minus y0. Similarly, delta of y 3 by 2, so this is 1 plus 2 divided by 2, and this is going to be y2 minus y1. And similarly, delta of 3 plus 2, 5 by 2, y 5 by 2 is going to be y3 minus y1. Similarly, delta of y7 by 2, so this value is getting calculated as y4 minus y3. So this is how the central differences are calculated. Even here also if you notice, these values are one and the same, but the convention are different. So this is called as the central difference operator. So like this actually we have defined three different popular operators: forward difference operator, backward difference operator, and central difference operator. So, but essentially what we are calculating is same. So depending upon the application, we are going to use the corresponding operators. Got it? Yeah, you can note down this. This is central difference. See, 1 by 2 convention is, here actually when we are trying to find out a central difference between these two values, what we are trying to do is this subscript and this subscript are added and then actually divided by 2, which essentially means you have taken the average of these two. That value is delta of y1 by 2. We are trying to identify a value which is in between and we are trying to associate it. So y0 and y1. So y of 1 by 2. And similarly, here also the central value is the average of this 1 and 2. So delta of y3 by 2. This is just a convention. So delta of central difference operated on y of 3 by 2 will give you a relation between y of 2 and y0. So y of 2 and y1, which is the difference of this y2 minus y1. Similarly, here also 2 plus 3 by 2 is 5 by 2. 3 plus 4 by 2 is 7 by 2. So like this actually y4 minus y3 is expressed as delta y7 by 2, which is the average of these two values 3 and 4 by 2. Got it, Pankaj? But anyway, actually we are not going to use this central difference. We work only on the forward and the backward differences. And then there are another kind of operators. So there are two other operators. Those are the shifting operator. So this shifting operator is represented with a letter called E. Now this E, if it is operated on any particular function, so let us say E, if it is operated on f of x naught, so this value is going to be shifted by a value of h. So this is how actually is going to be represented. So shifting by a distance of h is nothing but E of f of x naught is shifted by x naught plus h. And then here actually E of 2 into f of x naught, this is f of x naught plus 2h. So this is how actually it is going to shift. Whatever may be the power here, and then that many number of times the intervals are getting shifted. So this h is an interval between the two different subsequent values. So if you take the values like this on the x-axis, let us say this is x naught and this is x1 and this is x2 and this is x3, then this difference is treated as h. And then here actually if you want to express x2, this can be expressed as x naught plus 2 times of h. If you want to calculate x1, this is x naught plus h. If you want to calculate x3, this is x naught plus 3h. Now, for using this kind of relation, we are going to make use of this shifting operator. So, E is operated on a function f. So, this is going to give you a value of f of x naught plus h. So, this is how actually it is shifting. But essentially, the function value is getting shifted. That means, y naught is shifted to a location of f of x naught plus h. If you call this as y1, so this is E actually operated on y naught is going to be shifted as y1. Got it? So here actually E squared of y naught is equal to y2. So y2 is essentially f of x naught plus 2h. This is how it is going to shift. Got it? So e power p of y naught is going to be yp, and this is essentially f of x naught plus ph. So this is the popular relation. Understood? So this is just an operator. If it is operated on any particular function, it is going to shift the value of the function by an amount of, for the independent variable, it is this value getting multiplied by the difference. So that difference, if you add to x naught, whatever the value of y you are going to get, that value is represented by the convention of e square of f of x naught here. So this operator is called as a shifting operator. So as and when actually we see this shifting operator for a power of p, and this is going to be yp, and this yp is expressed as f of x naught plus ph. Understood? So and the next one is the averaging operator. So averaging operator is nothing but the average of the two values. And this is represented with a letter called mu, and this mu, if it is operated on any particular function, so mu of yx is treated as yx plus h by 2 plus yx minus h by 2 whole divided by 2. So this is the operator. So for this particular function, an average operator is operated, then actually the value which is half less than and half more than this particular value, and correspondingly take the average of these two, and then that value is treated as mu into mu of yx. So this is mu is not a multiplication. This is an operator operated on y of x. Got it? Understood? This average operator, exactly in the similar manner of shifting operator, this average operator also, it has a meaning of its own. So these meanings actually we are trying to understand here. Got it? So these are the conventions actually what we are trying to use in case of interpolations. So this terminology you have to be aware of it, and the meaning of each and every letter you have to be aware of it. And these operators also are interrelated to each one and the other. So relation between the operators. Now we'll take one by one. So first one, there is a relation of delta equal to E minus 1. So this is one operator. Delta equal to E minus 1. So for this actually, if you operate delta Yx, so delta Yx is nothing but you are operating a forward difference operator here. And this forward difference operator will give the relation that is Yx plus H minus Yx. So this is the forward relation operation. Now here Yx plus H is nothing but the function value of x plus h minus the function value of f of x. So this is how actually you can express this. These two are one and the same. So y is nothing but the function. For the function y is equal to f of x. So for a value of x, y of x is nothing but f of x. And this value is shifted by an amount of h, x plus h. So this one you can identify this as e of yx minus yx. Now from this actually if you take yx out, then e minus of yx. So this is another operator. Now delta of yx actually is coming out to be e minus 1 of x. So whether you operate a forward difference operator on yx, or if I operate e minus 1 operator on yx, it's one and the same, which essentially means that this one and this one are one and the same, which will give this relation. So delta equal to e minus 1. So this is one relation between the operators. Similarly, we have another relation. That relation is inverse delta. That is delta R is equal to 1 minus e power minus 1. This is another relation. Exactly in the similar manner actually we can find out this value. So delta, if it operated on yx, so this is inverse delta, which essentially means that, so this is actually the backward difference. So this backward difference operator, if it is operated on yx, so this is going to give yx minus h. So this is the backward difference operator meaning. Now here, if you put it onto the shifting operator, this is yx minus, this is going to be e minus 1 of yx. So why this minus 1 is a shifting operator, whatever may be the power, it is going to shift the value of y for an independent value of x, which is shifted by an amount of this value getting multiplied by h. So this is minus 1 into h is getting shifted. Hence, x minus h can be treated as e power minus 1 of y of x. So which essentially means that 1 minus e power minus 1 operated on yx. So which essentially means that delta or inverse delta can be treated as 1 minus e power minus 1. So or this can also be treated as e power minus 1 is equal to 1 minus delta, or this can also be treated as e is equal to 1 minus delta whole power minus 1. So this is also one relation. This formula we are going to use in case of Newton's backward interpolation formula. And this relation, whatever we have got here, so this one, delta equal to e minus 1 or e is equal to 1 plus delta. So this relation also we are going to use in case of Newton's forward interpolation formula. So this is going to be used in Newton's backward interpolation formula. This is going to be used in case of Newton's forward interpolation formula. Got it? So understood these derivations? Done. Noted. And the next relation is delta is equal to e power 1 by 2 minus e power minus 1 by 2. E power plus 1 by 2 minus e power minus 1 by 2. Yeah, this is the relation. Now delta actually, if it is operated on yx, then this delta operator is nothing but the central difference operator. The central difference operator is treated as y of x plus h by 2 minus y of x minus h by 2. So this is the central difference. Now this central difference value, this can be treated as e operated for an amount of 1 by 2 and then yx, and here e operated for an amount of minus 1 by 2 on yx. So this is e power 1 by 2 minus e power minus 1 by 2 operated on yx. So this is equal to delta of yx. So delta is as equivalent as that of e power plus 1 by 2 minus e power minus 1 by 2. So this is the central difference operator. Got it? Similarly, we have actually the averaging operator as well. So the averaging operator is mu. Mu, if it is operated on yx, so this is going to be yx plus h by 2 plus yx minus h by 2, and this is by 2. So this value is going to be 1 by 2 times of, this is operated e power 1 by 2 operated on yx plus e power minus 1 by 2 operated on yx, and this value is going to be e power 1 by 2 plus e power minus 1 by 2 whole divided by 2, and this operated on yx, this value is mu yx. So which is the averaging operator, or mu is as equivalent as that of e power 1 by 2 plus e power minus 1 by 2 multiplied by 1 by 2. Right? So this is the averaging operator. This is the central difference operator. Got it? You can note down this. Done? And the next relation is delta equal to E del. That is another relation. So to prove this relation, E del operated on yx. So del of yx is going to be E times of del of yx. This can be operated as yx plus h minus yx. Sorry, this is inverse operator, right? So this is going to be yx minus h. So this is del operated on yx. So if it is operated on yx, then this is going to be Eyx minus E yx minus h. Now if you operate E on yx, this is going to shift as yx plus h, and this is operated, it will shift by an amount of h, but there is a h which is getting subtracted here. Minus h plus h is become to 0, then this is going to be yx. Now this yx plus h minus yx is nothing but forward difference operated on yx. So E del of yx is going to be del of yx, or E del is equal to delta. This is one relation. And then delta E is also equal to delta. Del E is equal to delta. So E del or del E. So the operator are actually E del or del E also. So we'll prove this as well. So del E actually, if it is operated on yx, if it is operated, so E operated first, then del operated on y of x plus h. So inverse del, this is y of x plus h minus yx. So this is going to be delta of yx. So del E operated on yx is equal to delta of yx, or del E is equal to delta. This is another relation. Done. And another relation is delta e power 1 by 2. Delta e power 1 by 2, this is as equivalent as that of forward delta. So this is the central delta e power 1 by 2 if it is operated on yx. So first actually, if you operate this 1 by e power 1 by 2 on yx delta, so this is yx plus h by 2. So x plus h by 2, now actually this central operator actually operated on this. So central operator is nothing but plus h by 2 and minus h by 2 difference. So this is y of x plus h by 2 plus h by 2 minus y of x plus h by 2 minus h by 2. So this is the after operating the central operator. So this is y of x plus h minus y of x. So this is as equivalent as that of the forward difference yx. So forward difference yx is equal to delta of e power 1 by 2 yx. So if you correlate this operator, delta e power 1 by 2 is as equivalent as that of forward delta. So this is another relation. Got it? And the last relation is E is equal to e power hd, where d equal to d by dx. So E is equal to hd. First you note down this, I am going to explain that. Done? Okay. And this relation E is equal to hd. Now E is equal to, if you operate on f of x naught, then this is going to be f of x naught plus h. So x naught plus h is after operating E on this. So E f of x naught is equal to f of x naught plus h. Now this one, if we expand with the help of Taylor's expansion, then f of x naught plus h into f dash of x naught plus h square by 2 factorial into f double dash of x naught plus h cube by 3 factorial into f triple dash of x naught plus dash 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 up to infinity. Now this one, if I replace f dash as capital D and f double dash as d square and f triple dash as d cube, like this, actually if you introduce the convention, then this is going to be f of x naught plus h into d f of x naught plus h square by 2 factorial into d square into f of x naught, d square operated on f of x naught, and h cube by 3 factorial into d cube operated on f of x naught and plus dash 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 up to infinity. So if you take f of x naught on the operation 1 plus hd whole square by 2 factorial plus hd whole cube by 3 factorial plus hd whole power 4 by 4 factorial plus dash 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 up to infinity. Now this is operated on f of x naught. So here this is e f of x naught is equal to, if you notice, this is 1 plus x square by 2 factorial plus x cube by 3 factorial plus x power 4 by 4 factorial. Like this, actually this expansion is there. This is essentially e power x expansion, where 1 plus x square by 2 factorial plus x cube by 3 factorial plus dash 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 up to infinity. So this is e power x expansion. In place of x, this is going to be hd, which essentially means that this is e power hd operated on f of x naught. The left side is e operated on f of x naught, and e is as equivalent as that of e power hd operated. Got it? So this is another relation. So like this, actually we can correlate these operators one and the other. So this is actually the foundation or the basics that we need to understand anything that is related to the finite differences or the interpolation formulae. Got it? And there is something called difference equations, which are anyway not for our preparation, but there is a lot more research on this. Got it? So finally, interpolation formulas are the ones actually we are going to make use for this. Actually, some of these relations we are going to use there. Got it? So do you have any questions on this topic? Finite differences? Any questions? Okay. So if there are no other questions, I'm going to stop the class for today. In tomorrow's class, I'm going to discuss the Newton's forward difference formulae. So Newton's forward interpolation and the backward interpolation, and if time permits, even the Lagrange's interpolation also, we are going to discuss with some of the examples there. Got it? Yeah. So that's all for today. Thank you. Good night.